Yeah, you got your blood auger and your chocolate auger, right? And your pumpkin spice auger, right? I don't know what else there is.
We will be back to talking about why grad school sucks next week. Stay with us.
Welcome to Hello PhD, a podcast for scientists and the people who love them. Today on the show, we reflect on all the reasons we're thankful to be scientists. Stay with us.
And we're back. This is Hello PhD, episode 61. I'm Joshua Hall.
And I'm Daniel Arneman.
And we'll discuss the human side of science and life in the lab. Happy Thanksgiving, Dan.
I wish I had like a turkey call to make right now.
Gobble, gobble, gobble.
Yeah, there you go. Very festive in here. Very festive.
Look at all the turkeys wandering up.
Should have shut the door before we started recording.
The only turkeys in here are us.
Yeah.
All right. Well, big plans for the holiday weekend?
Thankfully, I don't have to travel. I'm pretty happy about that. Alternate years, I go home to Pennsylvania, and this year we won't do that. So I get to actually not get on the road or get on an airplane or wait in TSA. It's going to be nice.
That is nice. I'll be traveling, but just up the road, just a drive away, so not too bad. Looking forward to some good food and some pumpkin pie. Well, Dan, I know one thing I'm thankful for, and that is our listeners.
I agree with that. It's been a pretty incredible year.
Yeah, it has. This podcast would not really be all that enjoyable to do, and I don't think we would have kept going for 61 episodes if it was just us talking to each other every week.
I mean, we still would have talked to each other. We wouldn't have recorded it.
That's true. So we just wanted to take a second to say thank you to everyone who's out there that's been listening to the show, and especially those of you guys who reach out to us from time to time, your emails, your tweets. That really does help us to keep going. We love to hear from you, and ultimately, we do this for you. So thanks.
Yep, and especially thankful for everybody who's shared the show. I think it has grown in a way, we haven't advertised it in any way, shape, or form. So it's really just word of mouth, people saying, this has helped me, or this episode really kind of spoke to me where I was in my graduate training or in my postdoc training, and shared it with other people, and now it's really gotten a lot more listeners. Yeah,
it's been incredible to see how the listenership has grown, and so would just like to take a moment to encourage you to keep doing that. If you like the show and there's somebody you think would benefit from it, another grad student, a postdoc, whoever.
A faculty member who needs to remember what it's like.
Yeah, and the truth is we hear from faculty members from time to time that actually do listen to the show. So definitely take a moment to share it. You can also write us a review on iTunes. That helps boost us in the visibility and helps people find the show.
All right, Josh. Now, a key component of the show is always the ethanol section. So tell us what you got.
Well, I've got to cram these in when I can. I apologize, but
Tis the season.
We're having another pumpkin beer this week because when I was in Virginia and picked up the pumpkin beer last week, I actually bought two different ones.
You just could not help yourself.
I couldn't help myself. Last episode's was pretty specific and pretty regional. This one, I think our listeners probably could locate themselves in most places. This is the Dogfish Head Pumpkin Ale.
No second P there?
No, this is the Punkin.
Pumpkin, yeah.
Pumpkin ale.
Pumpkin pie, pumpkin ale, yeah.
Yeah, so let's try this. This is a more traditional pumpkin beer. Let's see what we think.
Yeah, I think it has a little bit of the pumpkin spice, but it is not the over-the-top, I'm eating a piece of pie. So to me, much more drinkable. There's a little bit of bitterness. I like it.
Yeah, this definitely has the spices present. Pretty solid pumpkin ale. I think, ironically, neither of us are that huge of fans of pumpkin ale. So I don't know.
You continue to buy them. So what is going on?
I guess pretty soon we'll have to move into the holiday beers.
Yeah, no, if I had to choose, I would take this one. I think this is more appropriate. It doesn't feel like I'm...
Yeah, last week's was I don't even remember all that. It was like chocolate chai, pumpkin, something or other. That one I was glad to have a taste of it. But this one, I could actually imagine drinking one pint for the year. You could
pull up to the Thanksgiving table with a glass of this and enjoy your turkey and your yams. And really, I think it would add to the experience rather than just being a distraction.
I agree. We'll have a couple of these left, so maybe I'll bring them to my Thanksgiving table.
Fantastic. Do it.
All right, Dan, are you ready for some science in the news?
I'm always ready.
All right, Dan, I have to be upfront. This is not necessarily a news article that is recent. Well, okay, this is not
Science not in the news. Do, do, do.
This is actually a lot about some news that came out about a year and a half ago, but a friend of mine who's a microbiologist recently shared this again. And I had forgotten about this story and think it's really interesting, but there was no science in the news segment back then. So
Okay, well, let's hear it. Let's
I want to share it. And I picked
warrants.
I picked this out just for you because I think you tend to be a very creative and innovative tinkering kind of guy.
That was what drew me to science in the first place. Yes.
Yeah, I think you'll appreciate this story. So this is about a scientist at Northeastern University up around Boston named Slava Epstein. And so what he became interested in was kind of this big problem in microbiology, and that is there are bacteria and microbes all over the place, all around us, but we're very limited in what we can actually study by what we can actually culture in the lab.
Yeah, not everything will grow in LB. That's not a natural substance.
Yeah, and so there's actually a name for this. This is called the Great Plate Count Anomaly. And that is, we've got our nice Petri dishes and our growth medium that we grow in the lab. But, if we can't grow it under these normal, traditional laboratory conditions, we're kind of out of luck. So there's all this biodiversity out there that really is a black box to us.
Yeah, you got your blood auger and your chocolate auger, right? And your pumpkin spice auger, right? I don't know what else there is.
That's right. Maybe we should try that. Try some pumpkin spice
It's
auger
been done.
for the holidays.
Done,
I actually did use chocolate auger when I was in graduate school. And the key secret is there's not chocolate in it. It's actually hemoglobin.
Oh, gross. So instead of growing 50 kinds of bacteria, now we can grow 200, but we're still not even scratching the surface, right?
That's right. So anyway, Dr. Epstein became very interested in this problem, and he actually partnered with another scientist at Tufts named Kim Lewis. And what they did was they actually went out to the beach near their area, and they collected sand. And, it's known there's lots and lots of bacterial species in
My
the
3-year-old
sand.
does this too. Where are we going?
So what they decided to do is they made these little chambers out of metal washers, right? Like you'd get at the hardware store. And so they made little wells out of these washers, and they diluted the sand lots and lots of times until the bacteria were so dilute that on average they were getting one bacterial cell for each of these little metal washer wells. But then this is what they did that was kind of cool. So they sealed the washer with a membrane. And so what this mesh membrane would do is it would allow water and nutrients to flow into the well, but the bacteria couldn't get out and other bacteria couldn't get in. So they took these washers and they took them back to the beach and they buried them in the sand where they came from. And so then they left them there for a little while. So the idea being, all right, what we're going to do is whatever bacteria happen to be in the sand, we've trapped a single organism in each of these little washer wells. We're going to put it back where it came from, and hopefully it'll be able to be happy and grow under those conditions.
So we're not in the incubator at 82% humidity and 37 degrees and all of the controls that we normally put on bacterial growth. This is sitting in the beach somewhere.
Yeah, they literally buried this guy back in the sand.
That guy with the metal detector is going to ruin everything, isn't he?
That's a good
I'm
point.
waiting for that. He's got his headphones on. He's like, oh, yeah, bacteria.
And then a grad student's whole thesis gets chucked into the ocean. So anyway, what they did was they went and harvested these metal washer growth chambers, brought them back to the lab, and sure enough, the bacteria had grown like crazy.
So they had everything they needed inside that little
Yeah,
thing.
absolutely. And so through this process, they discovered and described lots of new bacterial species that had never been known before. So that's pretty cool. But now what they've done is they've improved upon that initial crude design, and they've made these little chambers that they call isolation chips or eye chips.
Cool. Yeah.
Yeah, and so what these have is they're little plastic boxes that have lots of little wells, and so they can do the same thing. So they've gone out to places like the Arctic or even sampled from inside of the human mouth. They've loaded up these eye chip chambers with bacteria, then they go put them back in the Arctic, back in your mouth. And actually, I should show you a photo of this, Dan. This is pretty cool. They actually can load these onto a retainer. Can you see this?
Oh,
here?
that's
We'll post
gross. Yeah. I
and
see
put
it.
this back in somebody's mouth for a certain number of time, and all these bacterial species we never knew before can then grow in this chamber inside someone's mouth. they bring them back to the lab and they have enough they can study them.
Now you can sequence them and do biochemical analysis. So what is the point though, Josh? I mean, everybody knew there were lots of bacteria out there. Is this just discovery and trying to find new things to research?
Yeah, well, here's where it's gotten cool. So as you probably know, Dan, bacteria, especially bacteria in the soil, live in very close quarters, and so often they're jockeying for position and nutrients, so they tend to create their own antibiotics.
Yeah, it's like the scene from Braveheart, but underground
Exactly.
and very, very tiny.
Exactly. So what these scientists have been able to do with these iChips is actually they can isolate new compounds, new antibiotics from these previously undiscovered bacteria. And they started a company now called Novobiotic, which is all about testing antibiotics from these previously unknown bacteria. And there's one that they found called Teixobactin. And they determined that this new antibiotic acted against certain gram-positive bacteria. It could actually cure infection in mice, including Staph aureus and Mycobacterium tuberculosis, which you probably know are two human diseases that have gotten we've gotten in pretty bad shape with the amount of antibiotic resistance that exists for them.
Yeah, and I think people were losing hope about finding solutions in the near term that were going to keep us where we are in our medical advances. You know, if you think back 100 years, people died of disease. You know, they died of infections constantly, and we have lived without any sense of losing somebody to an infection for a long time. So it's going to be amazing to see how these develop. I'm looking at the structure here, and it is, you would throw up on your organic chemistry exam if this showed up. I mean, it is huge. It's a gigantic molecule.
Well, we can post a link, or if you just Google the name of this antibiotic, there's been some studies in Nature and other journals. But one thing that's been cool with some of these initial trials against staph and tuberculosis is there's been no detection of the bacteria developing resistance yet. So
but now there's
hopeful.
a much bigger pool of places to look. So even if this one ends up with some resistance, maybe there are 10,000 more.
Absolutely. And so I kind of wanted to end this story with a quote from the article I read that I thought you would appreciate, Dan. And this is from Jerry Wright, who is director of the Infectious Disease Research Institute at McMaster University. And he said, "Don't you just love simple little elegant things? You look in my lab and there are all sorts of machines that go ping. And here are these guys. They went back and said, maybe we're overthinking this. You don't need to have $1 million worth of equipment. You can go to Home Depot and maybe change the world."
Yeah, that is a really cool notion. I have often lamented the fact that science is no longer everybody's sport, and how, you know, we've talked about the Enlightenment where people are out flying kites to see if, you know, lightning does something, and here I just built a microscope. Mm-hmm. And now it has become an industrial process, and it's become something that's so expensive you couldn't even get started on your own. And I love this. It's a great story.
Absolutely. So just wanted to share that with our listeners. Let's move on, Dan. So as I mentioned in our last episode, with Thanksgiving on the horizon here in the United States, I wanted to just ask people, what do they like about grad school? What is good about grad school? Because we certainly spend plenty of time talking about ways grad school could be improved.
Yeah, and hearing from listeners who are in really tough situations, and you know, they may be second guessing their choice to go to grad school, but there are the upsides. People do go for good reasons.
Yeah, and so one of the things I did, Dan, to crowdsource the answer to what's good about grad school, I posted this question to a couple of the subreddits that are science and grad school related that I follow, and we got so many responses. It's pretty cool. So I just thought we could kind of read a few of these.
Yeah, sounds good. Let's get started.
All right. So the first one.
We apologize for any names that we butcher, mispronounce, and the people who have these names should probably apologize for choosing them.
Yeah, and if you're not familiar with Reddit, there's a lot of creativity that exists in the choosing of your screen name. So you'll probably get a kick out of these.
Try not to read anything that would get us remove our clean label on iTunes.
But the top comment actually came from Leopold the Llama, who said, "I have a very flexible schedule. I go to bed when I want. I wake up when I want. And if I need to leave during the day or take off, I can do it. As long as I get the work done, my advisor doesn't care when I do it. I get to drive my own research path and decide what I work on. Get to put this research out into the world under my name and be part of a larger global community, unlike an industry where most things are proprietary. I get along well with my advisor, and I have a ton of fun with my lab mates. I get to travel around the world on my advisor's dime for conferences. All in all, frustrating as it is sometimes, I am having a damn good time.
It sounds like Leopold the llama has just the perfect situation. Found the right advisor, is doing research that he or she really likes to do. And, I agree. The flexible schedule, it is not a 9 to 5 job, as everybody knows.
Yeah, and I will say, Dan, going through all these comments, which we wouldn't possibly have time to read them all, flexibility is the word that came up the most. So clearly, one of the initial things that comes to mind for a lot of grad students or people who are grad students is the flexibility, the lack of a 9 to 5 structure is something people appreciate.
Yeah, they're watching their friends go to work at, the bank or wherever, and you show up at 8 and you leave at 5 and you get 30 minutes for lunch, and it's very regimented. And the lab is not like that. I agree. It's kind of a cool environment.
Yeah, so along those lines, AZ Knight had to say, the flexible schedule is what I'll probably miss the most when I'm done with grad school. I don't have to worry about coming in late after a doctor's appointment or take a day off for a sudden emergency without contacting anyone or formally using sick or leave time. I'm having a kid soon, and the ability to basically work from home for the first few weeks without dealing with parental leave is invaluable. So the other thing that came up, Dan, was this ability to travel. And I think that's something that maybe is overlooked, but there really are a lot of opportunities to go to conferences, visit places you haven't been before, and often as part of your research grants or your fellowship.
Yeah, I didn't get to travel a lot, but the travel I did was very memorable. They're some of my favorite experiences. I remember some conference in D.C., and, the conference was great, but then getting to hang out with my lab mates in Washington, D.C. was, I'll remember it for the rest of my life. It was really fun.
Yeah, absolutely. So besides the flexible working hours and the travel, another thing that came up a lot were the people. And I think that's a hugely important part of the camaraderie that's experienced among people working in labs. Did you experience that when you were in grad school?
Yeah, the really amazing thing about working in science is how curious and interested people are. And it's about all topics. I mean, obviously people are interested in their own research and in science, but I've found that scientists are curious about politics, and they're interested in world affairs, and they are doing amazing, interesting, weird hobbies. I think you're a great example of that, Josh. They're people that aren't just going home and kind of watching 8 hours of TV at night and then going to bed and starting again. It's a really rich environment, and it's one of the things I love most about it.
Yeah, I guess if I reflect on myself as I advance through my scientific training, I feel like it changed me quite a bit, and in a lot of personal ways. And, I grew up in a small town and really hadn't encountered a lot of people who were very different than me. And going through graduate school and my postdoc, it really is an international endeavor. And I was around people from vastly different backgrounds and different cultures than things I'd ever experienced before. And I think it's really fundamentally changed how I view and see the world, just to meet and interact with and work side by side with so many people from so many different backgrounds. I think in a lot of ways, that education was one of the most important things that I encountered through my training.
Yeah, Stripes by Proxy on Reddit had a really good observation, I think. It's easier to make close friends when you're sharing a stressful situation, and sleep deprivation has eradicated most of your social barriers. And it's so true. It's like you're all in this together. I can remember before comps and some of the testing you have to do, and it's so stressful. And everybody's off in their own little world doing research, but then you get together, you're all exhausted, and it's just... you're stupid and happy and giddy, and you get through it together. There's a lot of support.
Absolutely. Yeah, Dan, one of the comments, actually can't find it now, but that I had read, talked about this notion of doing science with people, and, you would do experiments and then go to happy hour in your department and then go out to the bars on Friday night together. And I really remember that too. I remember that sort of social fun that you would have. And I think there is something about when you're with a group of people who are all going through a similar struggle, that really does forge these bonds that are pretty substantial.
Yeah, they last a lifetime, as I think we are evidence.
That's right, Dan. And I would be remiss if not to say you and I met in graduate school, so we would not be here if not for that shared experience.
And look at us now.
Look at us now. Sitting here talking about grad school.
Still talking about failure to launch. We can't move on. Like those guys who are like, hey, I was the high school football captain. Remember that? Uncle Rico from...
Man, you should have seen me do that Western blot.
It was amazing.
It was the best Western blot.
Someday we'll grow up, I swear.
Yeah, it was great. There were a few other funny comments I saw. This is one I think you will actually appreciate, Dan. Level 9 Trauma Center had to say they enjoy the access to the all-you-can-eat peer-reviewed paper buffet.
Oh, it is so painful to be outside of an academic institution. And I still go to PubMed. I'll share some of that with you in a minute, but I go there and I see the link, and if it says free, I'm like, yes! And if it says Elsevier, I say no.
Yeah, I take that for granted, still being in the academic setting is, I've always had access to all of the scientific literature at my fingertips, and, that's not out there for everyone.
Yeah, it's like food and water, and it's just out of your reach on the other side of these bars. And you're like, no, give it to me.
Yeah, people should actually go back and listen to our Sci-Hub and the Publication Pirates
Not
episode.
that we condone that, but there are other ways.
That's right. One of the last things that came up that I thought was funny was the regular and easy access to free food.
Does that still happen?
Oh, yeah. There's a lot of weekly seminars and meetings that have the free pizza. And I've certainly heard of some students and maybe even some faculty who are quite aware that, Tuesdays are microbiology seminar, then Wednesdays are genetics seminar. We can get the pizza and then the Chipotle. And
go for the learning, stay for the free food.
That's right. So anyway, it was really enjoyable to read all of these things. If you want to read all of the comments that people came up with, you can go over to Reddit. You can check out the Grad School and the Lab Rats subreddit and find my thread that was entitled, What's Good About Grad School?
Yeah, you might need to pick me up around the holiday season. Remember all the things that are valuable. I do have to say that while I was there, these weren't all obvious to me, but looking back, there are a lot of great aspects of it.
Absolutely. And of course, there was a decent number of jokesters who wrote graduating or getting out was the
being
best.
done. No, it's not a false statement. Getting done is a good thing.
That's right. Dan, what do you think about that you're thankful about for grad school?
Yeah, I've been reflecting on this a lot recently. Josh, as you know, somebody very close to my family was just diagnosed with a brain tumor. And that is a real downer in line with this episode of being thankful. But coming from the background I come from, and I don't know if you've experienced this, but you are able to go and understand that disease in a way the person can't. The person with the disease can't. And I found that just by having access to the literature, by taking the time and my experience in understanding it and reading it and knowing about science, I can digest that and then play it back to the person in a way that the doctors can't and won't. They won't take the time to actually explain it. And I find that it brings a lot of comfort. And I encourage everybody who has this type of training and you see people in your life that may be diagnosed with cancer or heart disease or they may be asking questions about, should I go on this diet or that diet? I really do encourage you not to be their doctor, but to help them to understand the science. I think it's part of our role. The other thing that's been really valuable to me, and it's really my thanks to everybody out there still doing research. I know I don't do it anymore. This diagnosis of this brain tumor, it's a stage 4 glioblastoma, and the median survival time is like 12 months. So this is the one you don't want to get. With all the radiation and chemotherapy, that might bump to 14 months as a median. So there are people on both sides of it, and we recognize that it's really dire. It's a really terrible thing to be diagnosed with, but in our research, we've been able to find some clinical trials. And so I've been spending a lot of time this week in PubMed and learning about a clinical trial that involves injecting a polio virus. So it's this modified polio virus. And I was going through all the research to understand how do you put in a polio virus that causes paralysis and poliomyelitis, this disease that you want to keep this thing away from brain tissue. And so the way the technology works is they've spliced in some different regions from other viruses that don't infect and can't survive in neurons. And the thing that has really struck me is how long it has taken to come to this point where 100 years ago somebody discovered a polio virus. And over the last 50 years and more recently, people have been working to understand just the basics of how this disease works. So they cured it. They were able to develop the vaccine a long time ago. But people continued to work to understand how it gets into the cell, how it chews up the cell's protein synthesis methods, how it takes over all of that stuff. So now there's this treatment that they've developed that is really based on all of that basic science over the years. That some practitioner has put all of this information together to basically provide some hope. And I don't know what the outcome will be, but as I was reading through these papers, I was really struck by this one figure in one of the papers where it's a Western blot, basically, of one of the ribosomal binding proteins that helps your cell actually produce protein. And 3 hours after poliovirus gets in, you can see the little band get smaller and smaller and smaller as it chews this thing up. And I was thinking to myself, like, some grad student probably ran that experiment 100 times. Mm-hmm. And they took that picture of that gel and it didn't look good. And they did it again and it didn't look good. But anyway, my point is, I'm so thankful that everybody is continuing to do this work, because I think it may not be this year or next year or in 10 years, but we will find these cures. And there's hope. There's hope because people are out there doing it.
Absolutely, Dan. First, thanks for sharing that. And it's true, it can be very easy to lose sight day in and day out when you're going through the stresses of your scientific training. You're doing that experiment for the second, third, fourth, fifth time. You're trying to get things to work. You're moving small volumes of liquid into tubes with other small volumes of liquid. It's very easy to lose sight of why we're doing the things that we're doing. And that was just a great reminder that hopefully will be motivation to everyone out there listening who's studying some of these really important questions to our health and well-being. This is why we're doing those things, and that work really does make a difference.
Yeah, so thank you to everyone. And it really is, it's meaningful to me, and I suspect that all of us, even the article you brought in Science in the News today, it may not be the thing you think of. You're working on virology. You don't think you're going to be working on a cancer cure, but the reality is it's all connected. And as we understand it, we can turn the things we learn into tools that really help people.
Absolutely. All right, Dan. I'm thankful for word origin puzzles.
Me too, because that's my gig.
What do you have for us this week?
Okay, the clue last week was, in the late 1700s, scientists discovered an element that they believed was critical for acid production. They were wrong. Do you know the element, Josh?
Oh, man. I did. I figured it out. I believe it is...
We ruled out hydrogen, right? Because that's water.
Yeah, we ruled that out. So I'm thinking production. I was thinking gens, like Genesis, generation.
You got that. You got the half.
I'm going to guess oxygen.
That is absolutely correct. Oxygen is an element discovered in 1790. And it was named oxygen because the Greek word oxys means sharp or acid. And gen, exactly as you said, formation. So they believed that this was an acidifying principle and that it was critical in forming all acids. Now we found out that there are oxygen molecules in some acids, but it is not critical for forming acids.
Well, yeah, and the OH groups tend to be actually the opposite, right? It
turns out a little bit extra. So this word origin I really enjoyed because now that it's fall here in the southeast, there is a tree you'll see out in the woods that is the sourwood tree. It turns kind of bright red in the fall, and you make sourwood jelly and things out of it. But the genus and species is Oxydendrum arboreum. So sourwood or acid wood is Oxydendrum.
Huh, so that still persists.
Still persists, although most of the places you see oxy now refer to oxygen, not to the acidifying principle. So a little bit different, but you can take that to your next trivia game, which you won't go to because you hate trivia.
Well, I don't hate trivia. Okay, are we really getting into this rant? Because I'm about to get going. I don't like when I go to a bar to hang out and catch up with a friend, and there's trivia going on, right? Because it's really interesting and engaging to the people directly involved in playing trivia, but there's nothing worse than being in a bar where trivia is going on if you're not playing trivia.
You didn't go for trivia,
yeah. And this just happened to us this week. That's why it's fresh.
So next time you go, Oxydendrum arboreum will be one of the clues, I'm sure. Let me give you the clue for next week, Josh. If your pipette tip and a non-sterile surface touch together, you may experience this problem with your cell cultures. I'll read it one more time. If your pipette tip and a non-sterile surface touch together, you may experience this problem with your cell cultures.
Oh, that's happened to me.
It's happened to all of us, of course. Remember, we're looking for a scientific word described with a clue, and once you get it, you'll find that the literal meaning of that science word is a phrase in the clue itself. If you think you know the answer, email it to puzzle@hellophd.com. and we will randomly select a winner from all the correct responses and send the lucky puzzler an Amazon gift card, for which they will be very thankful.
I'm sure they will, Dan. All right, this has been a great episode. I feel really uplifted. It was kind of nice to talk about all the things that we really like about science and scientific training.
Every once in a while, you gotta say what works.
You got to do it. We will be back to talking about why grad school sucks next week. Stay with us. Seriously, though, if you would like to get in touch with us, we'd love to hear from you. You can email us podcast@hellophd.com. You can always tweet us at hellophd or reach out to us on our Facebook page. As I mentioned, we would love it if you would give us some feedback. You can leave us an iTunes review or get in touch with us.
I feel like we have a very balanced approach where I say how it sucks and you say how it's great. This week we just both happen to say how it's great.
Yeah, well, maybe next week I'll go negative.
There we go. We'll do opposite week.
That's right. All right, everyone. Have a wonderful Thanksgiving if you're celebrating it, and we will be back at you next time.
See you next time.